Hey guys, and welcome back to Biotech Breakdown. In today's episode, we will be exploring an exciting topic that is not only cool but also ethical. Imagine being administered unknown drugs and possibly hostile medicine against your will. Sadly, this is the reality for many animals in research labs, as they experience this and sometimes lose their lives in the process. Animal testing is one of humanity's most inefficient methods for testing drugs and vaccines. It provides limited results and is simply unethical. That is why today we are going to be discussing the organs on a chip model. Organs on chips, or OOC, are microfluidic devices that mimic the structure and function of human organs. These chips are designed to replicate the physiological conditions and cellular interactions found in specific organs, allowing researchers to study their structure, function, and response to certain drugs. Now, let's dive into the mechanisms behind the OOC. Firstly, chip design. Researchers design a chip that replicates the physiological composition of the specific organ. Then, using microfluidic channels as artificial blood vessels, they are able to deliver media and nutrients to nourish the cells on the chip. Next, cell culture. After the researcher designs the chip, the cells are seeded carefully into the microchannels of the chip using micropipettes. These cells are then left undisturbed to grow for days or weeks, depending on the cell type and the culture medium. That's all there is to it. Two simple steps to create an OOC, which also brings some handy features. Let's explore a few, shall we? Firstly, mechanical forces. OOCs are also capable of replicating mechanical forces such as cyclic stretching or compression to mimic the physical attributes of specific cells. This can be extremely crucial for reproducing the mechanical behavior of certain organs like the heart or the lungs. Next is its ability to form a network with other OOCs. Now, suppose a researcher wanted to understand the impact of a drug on both the heart and the kidneys. By simply interconnecting the physiological chips, the researcher can simulate the impact of the drug on both the heart and the kidneys at the exact same time. Lastly, we have real time monitoring. Sensors and imaging systems are integrated into the chip to monitor various parameters such as cell viability, oxygen levels, pH, and the release of specific molecules. This provides us valuable data on the organ's function and response to stimuli. All in all, OOCs are revolutionary. They offer several advantages over traditional animal models. It allows for high throughput screening and can potentially offer individualized treatment. They provide detailed and accurate results since it is more representative of human physiology. Its handy features allow us to have flexible control over our tests and experiments. Last but definitely not the least, it is ethical. It isn't right for us to take an animal and experiment with it for our needs. OOCs forge a new path around this problem, leading us to an ethical future. Well, there it is, folks. All you need to know about OOCs. Make sure you tune in next week for our upcoming episode on the Prince of Biotechnology, CRISPR-Cas9. This is Biotech Breakdown signing out.